Hello, everyone, and welcome to the BRE 600 webinar on side draws in cumene distillation. Before I get started with the webinar, I would just like to take a moment to introduce myself. My name is Assis Patel, and I have been a support engineer at Bryan Research and Engineering for about 2 years now. And as part of the support team, my main job at BRNE is to focus on troubleshooting different technical, simulation, and process issues for our clients. So if you have used Promax in the past, there is a chance that if you called or emailed in, I was able to work with you and hopefully address your issues. Now, with that said, let's get started with the webinar. The main goals of this webinar are to first go over a process flow diagram of the cumene production process, then to do a brief introduction into Promax, and then to cover how columns are specified in Promax, as well as setting up specifications for columns with side draws. So let's first take a look at our process flow diagram for the cumene production process. So in this block flow diagram that we have here, the first block starts off with the alkylation or the creation of the cumene, and cumene is created typically by the reaction between propylene and benzene. For this process, what you're normally going to have as your direct feed is going to be some type of propylene mix with propane, depending on where you obtain your propylene from. The benzene that is required is normally recycled back from the rest of the process after it has been separated out and made up if necessary. Now, in addition to the main reaction, or the formation of cumene, there are two side reactions that happen in the alkylation section, and that is the potential formation of diisopropylbenzene, or DIPB, and triisopropylbenzene, which is TIPB. After we formed our cumene product, what we do next is send our propylene, our unreacted propylene, propane, and benzene, along with the formed cumene, DIPB, and TIPB, over to the rectifier section of the process. In the rectifier section of the process, the main objective is to increase the cumene purity of our product stream, as well as trying to separate out our other aromatic compounds and remove our unreacted propane and propylene mix from the process stream. So the propane and propylene that is removed in our rectifier section is then sent to a depropanizer, where we will recover all of the propane and propylene out of the top of a distillation column. And out of the bottom of the distillation column, we're going to recover some benzene, which would be sent all the way back to the alkylation part of the process. Now, in our rectifier section, we also remove typically the majority of the benzene in the rectifier section. This is somewhere around 50% of the benzene. The rest of the benzene is sent with the cumene, the DIPB, and the TIPB down towards the cumene separation process, which is what we're going to end up modeling here in just a few minutes. The goal in the cumene separation part of the plant is to fully concentrate our cumene product stream and obtain a product. That high purity cumene stream is typically going to be about 99.9 whole percent cumene. And what we're going to end up separating out is some benzene that we send back to our alkylation part of the process, as well as taking some of the benzene and sending it back to the rectifier section of the process, and taking the remaining benzene and sending it with the DIPB and the TIPB to the DIPB separation part of the process. Now, in the DIPB separation part of the process, what we have is a column that will end up removing the TIPB out of the bottom of the column. And from the top of the column, we're going to purge out some aromatics, And near the top of the column, we take off a side draw that is going to have a high concentration of DIPB, and we react the DIPB with benzene in order to form some additional cumene. That cumene that we form is sent to the rectifier section where it is mixed in with the cumene that is formed from our alkylation reaction. So that covers the overall process flow for the cumene production process. Now let's go ahead and take a look at a blank Promax file, and then we will draw out the two columns that are part of the cumene production facility. So if you've never used Promax before, you may still find the interface familiar. This is because Promax relies on Visio to provide the UI and the interface. So if you haven't used Promax, but you have some experience using Visio, this may look familiar to you. Now, in a blank Promax file, there are four main areas. The first area is at the top, and that is the Promax ribbon bar. Here in the Promax ribbon bar, we're going to have all of the buttons that we will need to create our Promax process as well as customize our Promax project. Now over to the left is the shapes list, and the shapes list is going to provide all the process streams and the blocks being the different process operations in the simulation, such as distillation columns, pumps, compressors, heat exchangers, so on and so forth. The shapes list is also going to include the process streams that we use to represent material flow in the process, as well as energy streams, which we use to represent energy that's provided either as heat or mechanical energy in a Promax project. Over in the center is a flow sheet, which is where we're actually going to draw out our process. So we take items from our shapes list and we drag them out to the flow sheet to draw the rest of the process. In the bottom area, we have the message log, which functions similar to a compiler if you're familiar with coding. What the message log does is it displays where the Promax project is after you've executed it, how close it is to being solved, and whether or not there are any errors or warnings that Promax has run into while you were running the Promax project. The very first thing that you do whenever you start a new Promax project is to go to the active environment in the ribbon bar and specify your thermodynamic property package and your list of components. So the active environment button can be found in the top left-hand corner of the Promax ribbon bar. Once you click on the active environment button, you're going to get a new window that pops up. And in this window, the first thing that I like to do is to name the environment that I have. So since this is just going to be a physical separation of cumene, I'm going to give my environment the name of PR environment to represent that I'm going to be using the Peng-Robinson property package since I'm just concentrating various hydrocarbons. Now, to actually specify which property package I'm going to be using in my project, I'll come down to my list of available packages. I will single click, and then I can start typing to quickly sort through my available packages list. So I'm going to type in P, and that's going to take me to the list of property packages that start with a P, and in this case, the first one is Peng-Robinson. To select Peng-Robinson as the property package for my simulation, I will go over to the left of the name, and I will check in the checkbox, which will set my current package over to Peng-Robinson. Once I have my property package selected, I can then define my list of components. To define my list of components, I will click on the Components tab, which is the second tab in my environment window. And here I can either scroll through my list of components, or I can sort through my list of available components by name, chemical formula, or the CAS number. So the three main components that we typically have going into the Cumene separation portion of our facility is first Cumene. So I'm going to type out Cumene, and in order to add Cumene to my list of installed components on the right-hand side, I can single click on Cumene and then click the right facing arrow. And now the next component that I'm going to add is my 1,2-diisopropyl benzene. And to add this, I can do the same thing by single clicking on DIPB and clicking the right facing arrow, or I can double click on DIPB and that'll add it to my list of installed components. And the last thing I'll need to add is my triisopropyl benzene, or 1,3,5 triisopropyl benzene. And now, since I only have one option in my available components list, at this point, if I press enter, it will add my available components over to my installed component. And so just like that, it added my triisopropyl benzene to my list of installed components. So these are the three main species that are available or are present in the cumene separation portion of our facility. So I'm done setting up my components list. And now at this point, I can either click apply in the bottom right-hand corner of my environment window to save the changes that I have made, or I can click OK, which will save the changes that I have made to the environment and close the environment window. After you set up your active environment in Promax, the next thing that you're going to want to do is to add our inlet stream. So in order to add an inlet stream to Promax, what we do is we go over to the shapes list on the left, scroll down to the Promax stream shapes category, and then we will drag and drop out a process stream. So I'll click on process stream and I'll drag and then I'll drop. And once I do that, you'll notice I have a red process stream on my flow sheet. Now this process stream is red because it's missing its specifications. An inlet stream in Promax typically has 4 separate specifications, and that is going to be a temperature, a pressure, a flow rate, and a composition. To specify our 4 different specifications for our inlet stream, what we will need to do is double click on the process stream, which will open up another window that is called the project viewer. And the project viewer in Promax is the window through which we'll be able to see all of our stream results as well as our stream specifications. And additionally, this is where we are also going to see the specifications and results for our different blocks. So going into the cumene facility or to the first distillation column in the cumene separation portion is a temperature of about 370 degrees Fahrenheit and then a pressure of about 70 psig. And in order to enter in those values, all you have to do is click into the third column or the total column, type out your value, and press enter. At this point, it's important to point out that you can also change the units. For example, if I wanted to enter in my pressure in terms of PSIA, I can click in the second column or the units box, click the drop-down menu, and scroll to select the unit that I would like. So for example, if I wanted to specify in PSIA, whenever I do that, you'll notice that the value has automatically updated because Promax converted my value from PSIA to PSIG. Another way to convert our units is to highlight our value in our unit box and to type over it. Additionally, we can specify the unit and the value at the same time. So for example, let me get rid of my number in the box for pressure and then type out 70 psig. Whenever I do this and press enter, Promax will specify my pressure at 70 and change the units over to PSIG at the same time. Now, the next thing I need to do is provide some type of flow rate. So let's just say we have about 1,000 pound moles per hour being fed into our process unit. The last degree of freedom that needs to be specified is the composition. To specify the composition of a stream, we'll need to click on the second tab or the composition tab, and then click on the specify button in the bottom left corner. This will open up the specification window, and the first thing we will need to do for our composition specification is to select the basis. So I'm going to select mole fractions as my basis, and then enter in a typical composition for a stream entering our cumene distillation section, which is about 80% cumene, 8% DIPB, and 12% TIPB. If we look at the bottom right-hand corner, we can see that it'll tell us what our total is. If our total adds up to 100%, we can then click OK in the top right-hand corner and save our information. However, let's say that our total was actually not 100%. So I'm going to change my 12 to 11.99. And now when I try to click OK, Promax will give me a message that says the composition for stream 1 is not normalized. Would you like to normalize it? And so what this means is, in order for us to specify a composition, it has to add up to 100%. And Promax is able to do that for you by normalizing the stream's composition. So it'll take the numbers that we currently have and increase them or decrease them, depending on what the total is, to make sure they add up to 100%, but all have the same ratio. So if I click yes here, it'll change my composition slightly and make sure that it adds up to 100%. Now I can close out of my project viewer and see that my stream 1 is now green. And what green means in Promax is that the stream or the object has all of the values or results calculated for that stream. So now that I have my process stream 1, let's go ahead and add in a distillation column. To add a distillation column, we'll go over to our Promax shapes list on the left-hand side. We'll go to Promax distillation columns, and then we have a few different selections for our distillation columns. The first is just a basic distillation column with no pre-configured reboiler or condenser. However, if you scroll through the list, you'll see that there are different configurations that have been pre-built, and so that you can drag and drop those in without needing to do anything. But in this case, I'll just show you what you would need to do if you would like to make your own reflux and reboiler loops. So if I click on my distillation column and drag it out, I can drop that off on my flow sheet, and I will see that it is red. The next thing that I'll do is drag out the other shapes that I will need for my distillation column. Now, for the first distillation column in a cumene separation facility, typically the overheads from the distillation column go into a purge and then go into a total condenser before being sent back into the top of the column once its pressure has been increased by a pump. So first I'm going to drag out a mixer and splitter by going over to my shapes list on the left, going to the Promax mixers and splitters, and dragging out a splitter. The next shape that I'm going to need is going to be my heat exchangers. So I'll go to Promax heat exchangers and drag out a single-sided heat exchanger. And then I'm going to need a pump. So I'll go to my Promax fluid drivers shape category and drag out a centrifugal pump. Now, a quick Visio shortcut for Promax is if you have a shape that is pointing in the wrong way, for example, my pump's outlet is here at the nozzle, then what I'll want to do is have the nozzle facing towards the distillation column. So instead of doing any configurations with the shape itself, I can select the shape by single clicking on it, and then pressing Control H to flip the object. Now, let me also add in what I need for my reboiler, which in this case, I can go to my Promax heat exchangers and drag out a kettle reboiler. Kettle reboilers in Promax, or at least in pre-configured columns, are typically also facing the other direction, so I'll single click on it and press Control H. Now at this point, I'm going to draw all the streams that I need to connect my distillation column with its reflux loop and the boil up loop in the bottom. So to do that, I can go back to my Promax shapes list and drag out different process streams, or I can use a shortcut called the connector tool in Visio to draw arrows. To access the connector tool, what you do is you press Control 3, and if you'll notice, that changed my cursor over to a black cursor with an arrow below it. This represents that you're in connector tool mode. Now, if you press Control 1, it'll switch your cursor back to the typical white cursor that represents just a regular selector tool. Now, to draw arrows in the connector tool mode, first I'll press Control 3, and what I can do is I can draw arrows from different connection points on our shapes. So a connection point on a shape, if I bring my cursor closer to a shape while in connector tool mode, you'll notice that it gets these gray points around it. These gray points represent connection points, or other words, outlets or inlets for those objects. And these are places where you can draw process streams from. So to draw my overhead process stream, I'll bring my cursor over the distillation column, and you'll notice that a green square has popped up on my connection point, showing that if I click and start drawing, it will connect my arrow or my process stream to that connection point. This box that is green on my screen can also be red depending on your version of Visio. So now I'm going to click and drag, and you will see a dashed line that represents my process stream and connect it to the other connection point on the splitter. I'm going to do the same thing between the splitter and the reboiler, and then I'm going to draw my purge stream. Now I'll do the same thing from my heat exchanger to my pump, and from my pump to my distillation column. Then I'll come to the bottom and draw the inlet stream for my kettle reboiler, the outlet liquid product stream, and the vapor boil up that's going back into the column. One other thing, or a few other things that we're going to need are our energy streams. So energy streams are connected to connection points that have red Qs by them. Our reboiler can function as a simple two-phase separator without any heat inputs, but for this distillation column, we're going to be adding in heat to the bottom of our column, so our kettle reboiler is going to need a Q stream. Q streams, as I was saying, can be connected to any connection points that have red Qs by them. So at this point, if you are using Promax 5.0, you can use the connector tool to draw arrows to connect to Q connection points, and it will automatically draw a Q stream. If you are using an older version of Promax, such as Promax 4.0, then you will need to drag and drop out an energy stream from our Promax Streams Shapes category. And to show you how that works, I'll go to my Promax Stream Shapes category. I'll drag out an energy stream, and I'll connect it to the arrowhead portion of my heat exchanger in the top of my distillation column to represent heat that is leaving, since this is going to be a total condenser. The last block that needs energy is my pump, because it needs some form of energy to use to increase the pressure of the feed stream. And that Q connection point is at the bottom, so I'll draw that using the connector tool. And now, since I'm drawing arrows, it's important that I switch back to the regular selector tool mode, so I'll press Control 1. Before I go any further, I'm going to clean up my flow sheet a little bit. So a few other shortcuts that are in Visio that you can use to clean up your Promax flow sheet is to adjust shapes by smaller margins. So if we see here, my stream 3 and my stream 6 are slightly crooked, If I want to fix that, I need to move both my pump and my heat exchanger. So if I want to move my heat exchanger slightly down, what I can do is I can single click on my heat exchanger, and then I can press the down arrow, and that'll take a big step. Now for my pump, let's say I want to also move my pump down, I can click on my pump, and this time if I hold down Shift and down, it'll move it in a smaller increment. And the more zoomed in you are, the smaller that movement is. Okay, so that straightens up my process stream. Now I want to go about specifying my blocks because as we can see, our blocks here are all blue. Now a blue block means that you have the minimum amount of connections, connection points populated on those blocks. For example, my pump needed an inlet stream and an outlet stream, as well as an energy inlet stream before it turned blue. But the streams around it are still red, which means that they're missing some type of specification. So the pump is a pretty good example of a basic block in Promax because it needs the one specification that every Promax object or shape gets, as well as an additional specification since it has a Q stream connected to it. So the pump needs some type of pressure specification, and every other block will need some type of pressure specification, and you're going to see that as we go about specifying the different objects on our flow sheet. So to specify a pressure change, we can specify that inside of the pump itself, or if we knew the outlet pressure, we could specify the outlet pressure in stream 6 directly. But in this case, let's just double click on our pump to open up the project viewer, go over to the second tab of the process data tab, and specify a pressure change of 5 psi. The other specification that's necessary is an energy specification. So we can either provide the direct amount of horsepower that the pump has, or we can specify the overall efficiency and let Promax calculate how much horsepower it takes to increase the feed stream up 5 psi. So a typical efficiency for a pump is about 70%. So I'll go ahead and specify that. And now I'll close out. The next thing that we need to specify is the amount of our stream that we're going to be purging off from the main reflux loop. So I'll double click on my splitter, go over to the process data tab, and I will set the fraction to stream 3 to start off at about 50%. The last specification in my reflux loop is going to be a pressure change in the heat exchanger. We would typically need to also set an outlet temperature or a temperature change inside the heat exchanger, but I'm going to show you how you can do that inside of the distillation column if you have a column with a total condenser. So for now, I'll just double click on my heat exchanger, go over to the process data tab, and specify a small pressure drop of about 3 psi. Then I'll close out of my project viewer and I'll work on the specifications for my distillation column. Now, the first specification that we're going to need for our distillation column is going to be the number of stages. So we'll see here in the connections tab that we have the ability to specify the number of stages in the top left-hand corner. By default, whenever you drag the distillation column, it starts with the minimum number of stages, which is 2. In the default ideal stage mode for distillation blocks in Promax, this means that you have 2 stages of ideal separation or 2 stages of ideal trays. So these trays do not represent the number of actual trays in the distillation column, varying on the process. Now, in our Cumene distillation process, because we are just concentrating a effectively pretty close to a pure component, and the other 2 components aside from cumene have relatively similar boiling points here. The real to ideal stage ratio in our column is pretty close to 100%. So the number of stages that we have in this column is going to be pretty close to the number of stages that you would have in an actual column. So for my number of stages, I'm going to change that to approximately 70 or 270, which is approximately around what the number of stages typically is. At this point, I'm going to go to the Process Data tab, and since I drew my column myself, I need to specify what the column add-ons are. The column add-ons stand for if there's any type of reboiler or condenser attached to our distillation column. If you drag out a pre-configured distillation column from the shapes list, this will already be set up for you. But since I chose to draw my own boil up and reflux loop, it's not specified. So first I'll need to specify that I have a reboiler, and the reboiler is our block K100. Once that's done, I can go to my column add-ons dropdown and select that I have a total condenser with reboiler. The next set of information I'll need to provide is going to be the pressure specification, which every block in Promax needs. This is set in the stages section of the distillation column at the very top under pressure change. Typically, this first column has a pressure change of about 10 psi. And the next thing that we're going to need is the pressure information inside of the column. So this can either be set by the inlet stream, or we can set a certain stage's pressure. In this case, I'm going to go ahead and set the top stage pressure, or the pressure of stage 1, equal to 60 psig. Now, I also want to be able to connect my feed stream, my stream 1. If I drag my project viewer down, we'll see that stream 1 is disconnected to my distillation column, and I only have the option to connect stream 1 to either stage 1 or stage 70, or in other words, the top stage or the bottom stage by default. However, I know that I would like to add my stream 1 to somewhere around the bottom of the column. So in this case, let's say I want to add stream 1 down on stage 60. In order to add stream 1 to stage 60, I first have to make sure stage 60 is displayed on the column. So to do that, you'll have to go to your Process Data tab in the Project Viewer and go to the Stages section in the Properties grouping, and then scroll through the stages till you get to the stage that you would like to show. In this case, I'd like to show stage 60. So I check on the Show Stage box for stage 60. Now, whenever I close out of the project viewer, I'll see that stage 60 is on my flow sheet, and I can click and drag stream 1 to stage 60. Now that I have my feed stream, the very last thing that I need to do is give my distillation column its additional specifications. And these additional specifications come from the Q streams that are connected to the reboiler, and typically the Q stream that is connected to the condenser. But in this case, since we have a total condenser, we will get the ability to add a temperature specification for our total condenser in the distillation column. So I'll double click on the distillation column and I'll go over to the specifications tab. Here by default, Promax provides us with a boil up ratio specification and a reflux ratio specification because those are the native variables for both a condenser and a reboiler. So what Promax does is by default, even if you have another specification, it's going to ultimately be looking at the boil up ratio and the reflux ratio and trying to change those variables to get the column to meet the desired specification. These are also the variables that Promax columns have the easiest time converging around. So before we go ahead and set up any advanced specifications like a purity of a product in the bottom stream or a amount recovered in the bottom stream or overhead stream, we're going to go ahead and set up a boil up ratio in this case, and then our condenser temperature. So first, we're going to start up with a boil up ratio specification of about 1. To specify my specification, first I'll need to provide a target value in the target value column. So I'll type in 1 there for my boil up ratio, and then I'll change this specification over from a calculation, which means that the variable will be calculated but not reported, or sorry, it will be calculated and it will be reported. However, the criteria for convergence is not set to meet that specification. Once I select specification, this becomes the main criteria for convergence of our distillation column. So our distillation column will not converge unless the boil-up ratio is equal to 1. Now I'm going to come to the bottom left-hand area and click Add to add a new specification. The first specification that I'm going to add is the condenser temperature. So I'll click down on the drop-down menu for type of specification and select a phase property specification. The specification name I'm going to change over to condenser temperature and then click OK. Here I'm going to select my stage as the condenser. I'm going to select the phase that this specification applies to as the total phase, and I'm going to select the property as the temperature. And at this point, I have a few different reflux conditions I can set. I can either have the condenser cool down the stream until it is saturated, or until the overhead gets cooled down up until it is at its bubble point, or I can set it to a subcool temperature, which is a temperature below the bubble point, or the certain amount of degrees that the stream is subcooled by. In this case, I'm just going to set a subcooled temperature because that will allow me to set a manual temperature of 80 degrees Fahrenheit and set it as a specification. And then I can click OK. Before running the column, I'm going to add in the other specifications as values that we can measure. So what's important here is that we are recovering a good amount of cumene in our bottoms portion. So in order to see how much cumene we're recovering, what I can do is click Add in the bottom left-hand corner, set my type of specification as a component recovery, and then I'm going to change the specification name over to cumene recovery in bottoms, and then click OK. Now, first I'll need to select which stream I'm looking at in terms of recovery, and that's going to be my bottoms liquid. I'm going to need to select which components I'm trying to check the recovery for from my available components list. In this case, I'm trying to look at the cumene, so I'll double click on cumene, and now it's going to compare the molar flow, which is my ratio basis of cumene in the bottoms liquid to the cumene that's coming in from the feeds. And it's going to determine what that percentage is. Let's just say we would like to be able to recover 80% of our cumene from the bottom of this column. However, this is a target. So what that means is Promax will report what the cumene recovery is in this value box, but it won't force it to be equal to 80% because it's only set as a calculation and not a specification. And now that I have all of my specifications set, let's just go ahead and execute the project. So I'll go ahead and close out of my project viewer, and I'll double check that all of my streams are no longer red, in which this case, all of my streams are maroon, my inlet stream is green, and my blocks are all blue, which means that the simulation is ready to be run. At this point, I can go to the top of the Promax ribbon bar and either select Execute Project, which will run my entire Promax project, or Execute Flowsheet, which will just run my currently viewed flowsheet. So once I click Execute Flowsheet, everything took a second to calculate, and then it all turned green. So let's see what our results are. If I double click on my distillation column, it'll open me back up to where my specifications were. We'll see that I'm meeting my boil-up ratio specification pretty accurately here, actually, at a value of 1, and that my cumene recovery is actually 88% right now. Now, the overall benefit to this initial column is that it enables us to take a side draw off of the top of our column, which is typically highly concentrated in cumene. To observe where we should probably take our side draw off of, we can take a look at the composition throughout the column. This can be done by going to the Plot tab in the project viewer for our distillation column, and then in the Profiles list on the left-hand side, selecting Components. Now here we can see that effectively our cumene concentration happens in the top portion of our column, whereas our bottoms product is going to contain our cumene along with effectively all of the TIPB and DIPB. So if we keep looking through our concentration in the top, we're going to want something that's pretty close to 99.9% because that's the greatest purity that we're looking for in our product. So even here at our higher stages, I'm still not quite seeing that, but we see a value, or the highest value probably of about 99.5% around stage 3 or 4. So what I'm going to do is I'm going to go to my process data tab. I'll go to my stages list and I'm going to turn on the show stage option for stage 3. Then I'm going to close out of my project viewer and draw a side draw stream on stage 3 of my distillation column. Now everything's unsolved because I have a new specification, which is going to be the flow rate of this side draw stream. So I'll double click back into my distillation column, and then I'll click on the specifications tab. Here we'll see that we got a new specification, which is the flow ratio specification. This flow ratio specification is the default specification that you get for any side draw stream on a distillation column in Promax. What it represents is the ratio between the amount of flow that is in that stream and the amount of liquid, and typically the amount of liquid on the stage that we are drawing from. So in this case, our flow ratio is going to be a ratio between the flow rate of stream 10 and the amount of liquid on stage 3. So what we're going to want to do is control this flow ratio based on the cumene purity of our side product. But first, let's get our column converged at a flow ratio of 1, since ultimately Promax is going to be manipulating this flow ratio to obtain any other results in our side draw. So now that I've set a value of 1, I can click on specification, and then I can close out of the project viewer and click on execute flowsheet again, and this will converge my distillation column. Then I can double click on my distillation column and see that my cumene recovery in the bottoms went down overall because now we have our side draw. But there are two other things that I would like to see, which is one, what the cumene purity is, and two, what the flow rate of our side draw is. So I'm going to add 2 additional specifications by clicking on the add button in the bottom left-hand corner, and first setting my type of specification as a component flow/composition. And here I'm looking for my cumene purity in my side draw. The stream that I'm looking for is stream 10, which is my side draw, and the component that I'm looking for is the cumene. And in this case, what I'm going to do is change my flow basis over to mole fraction so I can see what my mole fraction of cumene is in that side draw. And I'm going to specify a desired target value of 99.9%, but that's just going to be a comparison. So right now we only have about 97.74%, which isn't going to cut it. But before changing any of our specifications, let's also take a look at the cumene flow rate out of the side draw. So to do that, I'll go ahead and click the add button in the bottom left corner of our specifications tab, and then select composition flow/composition as our type of specification and name this as cumene flow in side draw. Click OK. Once again, select stream 10 and double click cumene to add it to our components to sum, and our flow basis can stay as molar flow in this case. And we'll see that we're getting about 94 pound moles per hour out of that side draw. So what we would like to do is, now that we have our column converged in Promax, and what happens typically is by default, our columns in Promax, if we take a look at the convergence tab, use the last solution that the column was converged at to start solving for our next converged state if we change our specifications. So since we've given our column a solution in which the purity of our side draw stream was about 98%, it's going to be close to the solution of what the flow ratio would need to be in order to reach a Cumene purity of 99.9% in our side draw. So I'll go ahead and go to the specifications tab, and I'll change my flow ratio back to a calculation, and now change my Cumene purity in side draw over to the specification. And I'll close out of the project viewer and hit execute flowsheet again. And everything converged, which means we're meeting our specifications. So when I double click and take a look at what's happening, I can see that our boil-up ratio specification is still 1, and we are meeting our Cumene purity specification out of our side draw, which ended up happening at a flow ratio of about 0.52. So now that this is done, what we can do is add in our second distillation column, which is going to have the function of obtaining the rest of our Cumene product as well as separating out our DIPB and TIPB. But before that happens, what I'm going to do is add a few callouts to my Promax project, which are going to show me values that I would like to see by quickly looking at my flowsheet instead of having to look in the project viewer. So a callout can be added by going to the Promax stream shape category and going to the callout and dragging it out. A callout can be attached to a stream by taking the tail end of the stream and gluing it to the connection point on the stream. And then you can click the white circle in the middle of the box for the callout to drag it around. To customize the callout, you'll double click on the callout and go through the list of properties and or composition values that you would like to see displayed. So in this case, I want to see my stream's Cumene purity or Cumene mole fraction and the molar flow rate of Cumene in that stream. So I'll expand the composition, I'll expand by species, I'll expand Cumene, and I'll double click on the molar flow, and I'll double click on the mole fraction. By default, it gives these values a significant figure of 5, and I would only like that to be 3, so I'll change both of those to 3, and then I'll click OK. Now this brings up my callout, and so I can quickly see it, but it is a bit bulky, so I'm going to trim down that bulk a little bit by double clicking on my callout, unchecking show titles, display individual phases, and then clicking OK, which reduces the bulk. And I'm still going to need to drag it out a little bit just so that it's not over any of the other parts of my process. Now there's a few other streams in which I'd like to see this value for, typically stream 4 and stream 8. So I'm going to click on my callout and press Control C to copy it, and then press Control V to paste. This will allow me to paste a callout that already has the molar flow and mole fractions customized to it, so I don't have to redo that whenever I attach it to a stream, such as stream 4 in this case. And then I can paste again, reposition my callout, and attach it to stream 8. Now I'm going to add my second distillation column. So first I'm going to highlight over my entire distillation column that I currently have, to select it, and then drag over that selection box just to give myself a little bit of more space. And now I'm going to go to the Promax distillation columns, and I'm going to add out a pre-configured distillation column that has a total condenser and a reboiler designated by distill TC, R. Here, I'll still need to draw my product streams. So I'll draw the other stream on the splitter, and I'll draw the liquid product from the kettle reboiler. Now I see that there's a little bit of congestion here, so I'm going to select my splitter, and when I do that, you'll see this yellow dot pop up on the name. And what that'll allow me to do is if I click on that yellow dot, I can move the name text. And now what I'm going to do is I'm going to add my number of stages as well as the feed stage to my distillation column here. So I'm going to double click on this distillation column. This distillation column is also going to have about 70 stages. Then I'm going to go to the process data tab and go over to my stages tab. While I'm here, I might as well specify the pressure change of about 5 psi throughout this column, as well as having a top stage pressure on stage 1 of about 25 psig. And the last thing that I'll need to do is I know that the feed is normally fed in around the top third portion of the column, so I'm going to feed in my feed around stage 20. So I'll check on the show stage 20 option. Now at this point, I can close out of the project viewer, click on my stream 8 and drag it over till the arrow connects to stage 20. At this point, I'll now just go about setting the specifications that I have inside of the distillation column. So I'll double click here. I'll go over to the specifications tab. And this time, I don't know how much I typically purge out. So what we're going to do is set a reflux ratio, which is going to set how much is being split out in that splitter that we have after the total condenser of either being product or being cold reflux sent back to our column. And in this case, I'm also going to start off with a specification of our bullet ratio. So I'll have a value of 2 for both of those, and then I'll check on the specification option. Now, I'm still going to need to specify my condenser temperature because this is still a total condenser. So I'll go ahead and go to the bottom left-hand corner and click Add. For my type of specification, this is going to be a phase property specification, and I will name this the condenser temperature, and then click OK. Once that's done, I'll set the stage as the condenser, the phase as the total, and I'll set my property once again to temperature. And I'll need to set my reflux condition to subcooled. Typically, this stream is subcooled down to 80 degrees Fahrenheit. And I will also set this as a specification and click OK. Now, the other things that are important for me to measure is going to be ultimately the Cumene recovery in the overhead portion of the column, or as from our distillate, as well as the Cumene flow rate out of our distillate, and the amount of Cumene that's left over in the bottoms of our column. So I'll add those 3 specifications before I run the column. So I'm going to click Add once again, and the first thing that I'll add is going to be the Cumene purity in my distillate. So I'll click Component Flow / Composition, and I'll name this Cumene purity in distillate, and click OK. For the stream, I'm going to select the distillate. The component I'm looking at is Cumene, and I'm looking at the mole fraction, and my target is going to be 99.9%. At this point, what I'm going to do is go to this line right by the name box and drag it out so I can see the full name of my specifications. Now I'm going to add my next specification, which is going to be the flow rate of Cumene out in the distillate stream. So I'll change this to Cumene flow in D for distillate, click OK, select the distillate stream, double click the Cumene stream and leave it as molar flow. And the last thing I'm looking for is the Cumene mole fraction in the bottom stream. So I'll go to my type of specification, select component flow / composition, say Cumene purity in bottoms, or just B, and click OK. Select bottoms liquid, double click our Cumene as the component that we're looking at, and take a look at the mole fraction. There is one more specification I want to take a look at, and that is going to be the Cumene recovery in my distillate. So I'll go ahead and click Add, go to my type of specifications and take a look at component recoveries. And this will be cumene recovery in distillate. Then I'll click OK here. I'll select my stream as the distillate stream. My ratio basis can stay as molar flow, and then I'll take a look at the cumene recovery and then click OK. At this point, I'm going to close out of the project viewer and see that I still need one more specification because some of my streams are red here, and that is going to be the pressure drop in my total condenser. So I'll double click on that heat exchanger, go over to the process data tab, and enter a small pressure drop of about 3 psi. At this point, I'll go ahead and click on execute flow sheet, and my column is going to converge. So now I can double click and take a look at how well I'm meeting some of these goals. So my cumene purity in my distillate is very high there, but the overall recovery in our distillate is pretty low at 43%. And ultimately, we have a lot of our cumene as the main mole fraction in the bottoms. So what we're going to do is try to minimize the amount of cumene in our bottoms and increase our cumene recovery in our distillate. But we know that we still want to maintain the purity. So the first thing that I'm going to do is get rid of my reflux ratio specification and instead try solving for a cumene purity. And then we'll see if I can execute this portion of our project. So I'll go ahead and a quick way to execute project is from the top of the project viewer. There's an execute project button there. And so everything went through here. This ended up increasing our cumene recovery because we didn't need to boil off so much cumene that we got 100% in the top. We only needed 99.9%. And the next thing that we'll do is see if we can minimize the amount of cumene in the bottoms. So right now it's 30%, 33%. So let's see if we can get it down to 20%. So I'll turn off my boil up ratio specification and set my cumene purity in the bottoms as the new specification, and then click execute. And now let's see if we can go lower. So from 20 to 10, everything worked out here. The reason I'm saying that everything worked out without being able to see the flow sheet is because I have this mini version of the message log in my project viewer. If there was any warnings or errors or approximations for my column, they would show up here. For example, we're seeing that it says the inlet pressure from P stream 13 is lower than our stage pressure. And that's because we have a pressure drop in our heat exchanger, but we don't have a pump before stream 13 enters in on stage 1. Which is not a problem because what Promax will do before adding stream 13 to stage 1 is increase its pressure, recalculate the properties, and then mix it in with the rest of the fluids on stage 1. So let's continue seeing if we can decrease our cumene purity in the bottoms to 5%. We'll re-execute here, and everything happened just fine. So now let's add more callout boxes. So I'll just go ahead and click on one of my old callout boxes and paste it. Add one to my product, and then also add one to my bottoms liquid. And at this point, we have the base model all specified for our cumene separation, so we can do more things, such as trying to minimize where we're losing our cumene product. We can probably try to minimize the amount in the purge up here, as that value is pretty high at 77 pound moles. We could also see if we could drop the cumene further from the bottom of our second distillation column, such that it's lower than 5%, but we see that that's only about 10.5 pound moles per hour of cumene. And ultimately, the amount of, or the purity of the cumene here is going to impact the heat exchanger duty in our reboiler. So you'll want to observe that value and see if it's reasonable. At the moment, we're processing about 1.4 times 10 to the 7th BTUs per hour. So that can be considered a high value. If that's too high for what you have, then you know you need to lax up on some of the specifications. And that's just the difference between design and what's feasible. So Promax is telling you that this is all capable of converging, and this is how your separation would look, but it's on you as the engineer to monitor what the duty would be and convey that over to either a steam flow rate or a hot oil flow rate and make sure that's something that's actually feasible that you could use at your facility. And the same thing for the heat duty in the first column. We need to make sure that this is a feasible amount of heat duty. If we're thinking of increasing our flow rate or our recovery in stream 10, we need to boil up more cumene, which is going to take more heat. So we need to see if that's okay to do. And we need to see what impact reducing this purge on the top would have. Um, Another place to look at your heat duty is going to be these condensers. We need to make sure that amount of cooling is okay and to make sure that the volume of liquid re-entering the column is going to be okay. So with that, I hope that you were able to learn something or take away something from this webinar, whether or not it was a how to use Promax or a quick tip on a shortcut or a better look at how you can analyze and interpret your results, or if it was how to set up distillation columns, as was the main goal. If you would like to contact me, or if you would like to get in touch with our other support team, you can call in at 979-776-5220 and ask for technical support, and you will be sent over the phone to one of us where we will hopefully be able to help you with your issue. Additionally, you can send in your questions to support at bre.com, and that will get sent to all of our support team in an email format where someone should respond to you within the hour. Thank you again for attending the course, and I hope you have a great rest of your day.